This video is a quick introduction to containers and the differences between virtual machines and containers. And we're just going to cover very briefly the various application execution models and talk about the essential features of a container system and highlight the differences between virtual machines and containers. So in early computer systems, things were relatively simple. We had the physical hardware, the memory, the storage was fixed, and at any given point in time, the system could only run a single application, and that application required a certain amount of memory for the code and data, and either it fit within the physical machine or it didn't. And so you might have some applications that are smaller, some that are larger. And so the main problem with systems in the early days is just that the utilization of memory wasn't necessarily very good. You might have an application that is CPU bound but doesn't require much memory, or you may have another application that is memory bound but doesn't require much CPU. And so usually for a single application, you were not making the best use of the memory or the CPU. It was rare that you would be utilizing both of those resources to capacity. And although the early operating systems didn't totally address this problem, they did address the one problem of being able to load and unload applications efficiently. So in the early days, applications ran directly on the underlying hardware, and they would have to be loaded and unloaded essentially manually by the computer operator. And so one of the early innovations was the implementation of an operating system for a computer system. So the operating system is the body of code and data that's resident in the system all the time. And in the early days anyway, the main feature of the operating system was to facilitate the loading and unloading of applications. And so the operating system is the same all the time, but it allows switching between different applications. So changing applications is a little bit easier with an operating system, but when the OS can only run a single app at a time, we still have this utilization issue. We may not be getting the best use of memory or the best use of the CPU. And so the next major development with respect to operating systems is the ability for a computer system to run multiple applications concurrently. And so the idea is we have a single operating system, its code and its data that's resident in memory all the time, and one or more applications that are resident in memory and running concurrently. And it's usually the case that they can occupy different amounts of memory, they can utilize different amounts of CPU, but because we have multiple applications running concurrently, the expectation is that we're going to get better utilization of those underlying resources of memory and of the CPU. And just one of the problems with the multiprocessing model is there's a single operating system, and all the applications that you want to run are tied to that operating system. And so you don't have a whole lot of flexibility if you have applications that need different operating systems or require different versions of an operating system or versions of libraries or support programs or whatever is required. And so the way that problem has been addressed is by way of virtual machines. And these come in two flavors. One of which is using what's called a type 2 hypervisor. So in this model, we have a host operating system, and on top of that, we have a type 2 hypervisor, and then on top of that we have the various virtual machines. And each virtual machine is going to occupy a fixed amount of memory. It is going to have their own guest operating system independent from each other, and then again one or more applications running inside of each virtual machine. The second type of virtual machine organization is the type 1 hypervisor, and so in this case there is no host operating system. The hypervisor runs directly on the underlying hardware, and then we have the virtual machines as before. So the different guest operating systems and the applications running on top of those. And then finally, we have the container model. And in this model, there's a host operating system. There is a container engine that supports the execution of multiple containers. And usually we define a container as a single application bundled up with all of its dependencies. And just the kind of key concepts associated with containers are that of the underlying image, the container itself, the container daemon, and the container client. And the underlying container image is really a snapshot of a file system. So the image contains all of the binaries and libraries that are required to have a complete running container or support a single application. And usually these images are hierarchically developed, or they're layered. And so we have some kind of base image, and for a given application we add in the required elements that are required for it. So any kind of libraries or other tools or whatever is required built on top of another image. So that's the model upon which images are built. And then we have the concept of a container, which is really an executing image. So we have the underlying base image, which is read-only, so that's the contents of the file system initially. We have the contents of memory, so the code and data for the executing application. And the container also maintains a record of the changes to the file system. So because the underlying image is a read-only image, anytime the application makes a change to the file system, that has to be recorded in such a way that it doesn't change the underlying base image. The benefit of this structure is that the underlying image can be shared across containers. So it can be very space efficient in the sense that we can have hundreds of containers running off the same image, and really we only need a small amount of storage to record the file system differences for each separate container. So that's very efficient. And then we have the concept of the container daemon. So this is a background process running on a particular host, responsible for managing all of the containers running on that host. So managing memory, managing the file system, and so on. And then usually what a user would utilize is a container client to either manage those images or manage the containers that are running on a host. So in terms of managing the images, the client program would contain commands to build a new image, push an image to a container registry, pull or download an image from a container registry, or delete an image. And the client program could also be used to stop or start or delete containers executing on a given host. And usually that's a local host, but the client can also be connecting to remote hosts to start and stop or manage containers there. So just to summarize the differences between virtual machines and containers. So virtual machines are heavyweight in the sense that they have a complete operating system and a fixed amount of memory that's allocated to them, whereas containers are relatively lightweight. So they just contain the application and the dependencies. The virtual machines, again, we have a full-blown operating system duplicated across each virtual machine, whereas with containers, we can share the underlying images. So there's more sharing involved in the terms of containers, which are more efficient. And virtual machines, due to their nature of having a full-blown OS, they're obviously going to be slower to start up, whereas containers are going to be much quicker to start up because they just have the application code and any additional dependencies. And so with virtual machines, you do get the benefit there really is this isolation in the sense that you are having completely independent operating systems executing, whereas containers are relying a little bit on the underlying host operating system to supply those low-level services. And again, in the case of VMs, you're probably going to have to allocate the memory up front, although probably it can be resized while they're running. Whereas containers, the memory requirements can grow or shrink on demand. Obviously, it's going to be limited by the amount of memory available on the underlying host. And so that really is just kind of a quick overview of containers and their differences when compared with virtual machines.